I would like now to welcome Elisa Farella from Fondazione Bruno Kessler, because we cannot have a session this day and age without mentioning AI. We have an expert with us. Elisa is actually a researcher from Fondazione Bruno Kessler, more specialized on, I think, I would say, on architecture and but also on AI, and we'll learn a bit more about interesting tools that were developed and are now made available.
Thanks, Alex. So good afternoon. I'm going to briefly introduce some of the tools that we developed within the 5D Culture project. And basically, these are AI-based, but also we will see one is AR-based, so an augmented reality framework that we realized within the project. So a set of tools for empowering and enhancing some historical sources, and in particular, we are talking about historical maps and historical photos. So these are these three tools. The first two, Vivid History and History Lens, are based on the empowerment of historical photos, and the last one, Urban Rewind, is dedicated to historical maps. Vivid History, so this first tool is composed by two modules. The first one is for the automatic colorization of the grayscale historical images, while the second module is dedicated to the creation of these 3D effects from single photos. About the first module, this is an AI solution. We adapted some AI libraries, quite famous, Paddlegun and the Oldify, that are generative adversarial neural network. Basically, we have here a generator that is able to learn some samples, some data, but also to generate some negative examples. And the discriminator, in this case, learns how to discriminate between the real and fake data. This is quite powerful for creating good predictions. And the second part is a library called 3D Photo and Painting. So for the creation of these 3D effects, we have a first part with the depth estimation, a second part that is able to recreate, to in-paint the hidden regions with the context-aware approach, where so when the camera will move for creating the 3D effects, we can have a complete scene to represent. And let's see some results of this first tool. We have here the automatic colorization and then the creation of these 3D effects. You can select one module or use both as you want. Some other examples, and this tool is particularly powerful when we have people that are represented in the scene, or monument. Like in this case, we have a beautiful picture of Trento. And finally, we can have also other kind of movements of the camera, so other effects like in this case. Okay, let's move to the second tool. This is basically a framework that we realized for the realization of augmented reality application for the visualization of historical photos in urban context. So this tool is composed by two parts. For the first part, we need to use a library that is called Immersal. With this library, simply with the smartphone, you have to map your environment where you want to create your application. So on the top, you can see the point cloud that is created from the for the libraries, simply walking through the environment or through a square and so on. And finally, we prepare this framework within Unity 3D for creating your own application. So basically, you need only to put your content within the scene. Here an example. So this is the map that you created with Immersal libraries. You have to put your content, in this case, historical photo, using the same position, the same location from which it was taken in the past. And then the final results, so the user had to scan the environment where the application was created. So the user is relocalized based on the map they created in the first step. And then you can visualize your historical photos, and you have also other possibilities like to add descriptions or some effects like transparencies and so on. And let's see the last tool, Urban Rewind. For those of you that were here 2 days ago, we presented the first part of this tool. This is an AI-based tool for the automatic creation of 3D city models, starting only from historical maps, vectorized historical maps. So the tool is composed by two parts. For the first one, we developed a new methodology, a new tool for the automatic vectorization of historical maps that is based on deep convolutional neural networks. And the second part, the tool that will be shared, that is another tool so for the automatic 3D city modeling that is based on other AI solutions that are machine learning regressors. So for the automatic vectorization, we created this tool that is called the Map2GIS. It is a semantic segmentation tool, so based on this deep convolutional neural network that is called DeepLab V3. So basically we can go from a raster to a vector representation of historical urban context. In this case, the tool is working with the vectorization only of building. And here are some examples on what we are working on within the 5D Culture project. Thanks, Sander, for this map. The Dresden map from 1911. So this will become also a QGIS plugin. And then for the automatic city modeling, we developed this pipeline that we optimize within the project for the automatic derivation of information of building height from maps of the past. So basically starting from some digitized historical maps and using these machine learning regressors, we are able to train a model and then to derive automatically the height of the to predict the height of the building in the past. So this is basically a predictive modeling techniques. So we will be able to predict some variables based on one or multiple known variables that we call predictors. And once the model is trained, we can infer so the building height that is our unknown datum. For the tool that we will release, you will have the possibility to select one of these 4 regressions model, and you have also some metrics in order to understand what is the reliability of your results. So this is an example of the first part, so the vectorization that we now are automatizing. You need some training data for your network, in this case, some topographic data of current historical context. And then you have to compute in a GIS environment these predictors or features, both on your training data and on the maps to predict. So we grouped them as some geometric predictors, like, for example, the area, perimeter, number of vertices of each building footprint. Some neighborhood predictors, like, for example, the distance between the centroid of each building footprints, and some positional and categorical predictors. So, for example, if we have towers, if we have a civil or religious buildings, and so on. So this is an example of these predictors or features computation. And we experimented with the previous project this methodology that now we have optimized also with the parameter that you can select for the prediction. And this is these are the new results on the city of Dresden with a first reconstruction of the historical context. And here, briefly, what are the new results that we are achieving? Thank you. Finish.
Thank you very much, Elisa.